Okay, folks, we're back again. Now, this is 8.6. We're talking about perimeters and areas of similar triangles. So before we were able to find the missing sides of similar polygons, whether they were triangles, quadrilaterals, all that good stuff. But now we're going to find perimeters and areas, and how we're going to see how they compare with similar triangles, and actually with any type of similar figure. So that's my bad, because that should not say triangles, it should say figures. All right, good. All right, here we go. So right here it says that we have trapezoids that are similar. Now, what's the ratio of their lengths? So right off the bat, I'm telling you they're similar. So what's the ratio of the lengths of their corresponding sides? 6 to 9, which we very well know is going to be reduced, and that's going to reduce to, what is that going to reduce to? You got it. It's going to reduce to 2 over 3. So 2, this is going to equal 2 over 3. Now, this is their similarity ratio. So here we go. Similarity ratio, how they're similar, is going to be, that's not pretty at all. Similarity ratio. I wonder if this will read my writing. Let's see. Let's try it. Yes. Genius. Similarity. The similarity ratio that they're going to have, we already decided it's going to be 2 to 3. Okay? So when we decided it's 2 to 3, we're like, all right, here we go, 2 to 3. Now, what about the perimeters? What is the ratio of their perimeters going to be? Now, this is actually pretty simple, because the perimeter ratios, okay, their perimeter ratio is going to be the same. It's going to be equal to their similarity ratio. It's going to be the same, because really, all these lengths are a 2 to 3 ratio. They're all the corresponding sides are 2 to 3. So if I were to add up all the sides and all this side, even if I reduce it, I should still get a similarity ratio of 2 over 3. Now let me write that word ratio. These are all ratios. So ratio, oh no, ratio, and ratio. Okay. Now the only one that's a little different is going to be their area ratio, because area is two-dimensional. Okay, when we're talking about area, we're talking about all the space in between. Now, that means that it takes it to a different level, because when we talk about area, it's two-dimensional, so we always usually square things or times them by something else. So it's going to be really easy to remember. How do we get the area ratio? Well, it's pretty simple. You just take the similarity ratio and you're going to square it. So think of ratio, the area ratio. What you could do with this guy is you just square this guy. So you take the similarity ratio, which is 2 over 3, and you square the 2 and you square the 3. What is 2 squared? That should be a 4. What is 9? I said it already. 3 squared is going to be 9. So the ratio between their perimeter is going to be 2 3's. It stays the same as the similarity, because it's just the length of the sides, correct? Perimeter is just the length of the outside. But area takes it to a second dimension. It's two-dimensional. So the ratio of the areas are going to be squared. Or the ratio of the area is really the similarity ratio, but just squared. So this is going to be 4 to 9. Okay? So pretty basic, pretty simple. Go ahead and write those notes down if you haven't. Stop the video and write the notes down. Okay, so when we're all done, here we go. It says here, these are the directions. This is your homework. Your homework is going to be 2 through 18 even. So if you haven't written that down yet, you're going to write down your homework is problems 2 through 18 even. That means there's only 9 problems for homework, but I'm going to do lots of examples with you guys. So here we go. So it says here that the figures, okay, it says the figures in each pair are similar. Compare the first to the second figure. Give the ratio of the perimeters and the ratio of their areas. All right, here we go. First of all, let's talk about their similarity ratio. Okay, so we're going to go ahead and talk about similarity ratio. Let me say, all right, similarity. Whoops, let's make that a little bigger. Similarity. I like making this little graph, this little part here. Similarity, we're going to talk about similarity. We're going to talk about their perimeter, and we're going to talk about their area. And now I'm going to make area in a different color, because area is handled a little differently, and that's okay. We'll make it green this time. All right, here we go. So in order to find these, the similarity ratio, and I already told you guys, they're similar. So it's going to be a 2 to 4. Well, of course, we're not going to just leave it 2 to 4. We're definitely going to reduce the 2 to 4 and have the 2 to 4 not what I wanted. Oh well. Become 1/2. So their similarity is 1/2. Now, what's their perimeter ratio going to be? Remember, the perimeter ratio is just going to be the same thing as their similarity ratio. It's going to be 1/2. Okay? How do I get the area? Now the area, that's the different one. The area is where I get to square. Okay? Because area is usually square feet or square inches or square meters. So you're going to square the 1, you're going to square the 2. So what is 1 squared? Was 1 times 1? Oh, you got it right. It is 1. 2 times 2, or 2 squared, is 4. So when I compare the perimeter, or the similarity ratio, I compare the two, I get 2 to 4, which is 1/2. Which means the perimeter is going to be the same ratio. But their area is squared. The ratio is going to be squared. And we're going to be doing different things with this ratio later on. I just want to show you that right now. That's how we get the different ratios between the two different figures. All right, let's move on to this page right here. Same thing. Okay, I believe this is number 3 and this is number 4. So, I'm sorry, number 2 and number 3. So this number 2 is actually part of your homework, and this is number 3, which you can use for notes. Okay, so again, I'm going to go back over here and I'm going to copy that little thing that I made here. Okay, similarity, area, perimeter. Let's go back here. And then we'll make a second one for this one over here. But we'll make this one, I like the area. Oh, we'll make these different colors over here. We'll make these guys red. And we'll make area purple. Okay, here we go. Alrighty, so the similarity for this number 2 here, this is the one that you want to have for your homework. Okay, so it's going to be from the first figure to the second figure. Okay, I'm not going to go from little to big because they want the first guy against the second guy. So similarity, it's going to be an 8:6 ratio. An 8:6 ratio. Which we know we're not going to leave it as 8:6. We're going to actually make it into 4:3. So let's go ahead and do 4:3. What's their perimeter going to be? Their perimeter should be the same, 4:3. How do I get to their area? I take the same similarity ratio and I just square it. Okay. Remember, similarity 8:6 reduces to 4:3. Perimeter is the same, 4:3. And I just square this to get their area ratio of 16:9. Okay. There's area, and oh, and there's perimeter. Let me undo that. That was not as pretty as I wanted it to be. There we go. Okay, there we go. So it's perimeter and the ratio of the areas. All right, moving on to this number 3, which is just going to be for notes. 14/21, their similarity is 14/21, so let's change to red here. 14/21, well, you know that they can both be reduced by 7, so this becomes 2/3. That's the similarity ratio. What about their perimeter ratio? The perimeter ratio will still be 2:3. Okay, can you try to figure out the area? What do we do to get area? We're going to take 2:3, and we're going to square it. I get 4:9. Okay, so these two guys have a 2:3 ratio, but their area ratio is 4:9. Okay, moving on to the next problem. Okay, it says here, this is an example. Now, this is an example of some of the problems that we're going to come up against. Okay, so it says here the perimeter of GHIJ, so of this parallelogram, is 20 centimeters. Now, it says the figures in each pair are similar. The area of one, I'm sorry, I should say the perimeter. Whoops. The perimeter of one figure is given. Find the perimeter of the other figure to the nearest whole number. Now, how would I go about doing that? Well, first of all, I'm going to figure out what their similarity ratio. The similarity ratio of this parallelogram to this parallelogram, as you know, is 4:6, which reduces to 2 or 3. Now, we also know, so this is their similarity, right? This is how they're similar. Similarity ratio. What about their perimeter ratio? their perimeter, it's going to equal the same, 2 over 3. Now, I know that the perimeter of this guy right here, this smaller one, right, because we said this is 2 to 3, is actually 20. So what I'm going to do is I'm going to set up a proportion using the perimeter ratio. Okay, this is the perimeter ratio, and it equals 2 over 3. Now, where do you think I'm going to put the perimeter of the smaller one? I'm going to put it up top. And since I don't know what the perimeter is of this big parallelogram, I'm going to put x over here. So again, what you see what I'm doing, okay, and know that this is a separate over here, is that the perimeter ratio is 2 over 3. So I'm taking that perimeter ratio and I'm setting it equal to a proportion of the perimeters. 20 for the small guy and x. And all I'm going to do from here is, as you guys would guess, is cross multiply. I'm going to say 2 times x is 2x equals 3 times 20, which is 60. And you guys can do the math pretty easily here. X is going to equal 30 because I'm going to divide each side by 2. X equals 30. So this guy, when this guy had a perimeter of 20, this one had a perimeter of 30 because of their length, of their perimeter ratio being 2 to 3. Okay, pretty basic, pretty simple stuff. Okay, now what happens here on this one? Let's do another one. This is another example one. Okay, this is how would I find the perimeter of the larger triangle? Well, let's first figure out what's the similarity. So I'm going to now start writing SR. What's the similarity ratio? Similarity ratio is 12 to 4, which we know this reduces by 4s, and I get 3 to 1. Meaning this guy is 3 times bigger than this guy. Okay. Well, this also means that this is their this is their perimeter ratio, right? This is their PR. This is the perimeter ratio. So I'm going to take the perimeter ratio of 3 to 1, and I'm going to compare it. Now, they tell me the perimeter of the small guy is 12, so where am I going to put that 12 on this proportion that I'm creating? I'm going to put it in the bottom, and then I'm going to put this guy up top. Cross multiply, 1 times x is x, or 1x. 3 times 12, 36. So while this has a perimeter of 12, this is going to have a perimeter of 36. How did I do that? I just set this guy at the bottom, this 12 right here, because it's the smaller guy, so I set it with the smaller number. And I put x up top to find out what was the perimeter of the larger. And that's it. Alright, keep going on. What happens when they want you to find the area of, here we go. Now what happens when they want you to find the area of a polygon when they give you their similarity ratio and the area of one of them? All right, here we go. So we're going to do the same thing. We're first going to find the similarity ratio, which we know is 3 over 6. But 3 over 6 really is 1/2. But now I need to use, I'm not going to use the perimeter ratio. If I have the perimeter ratio, but I'm not asking. It says the figures in each pair are similar. The area of one is given. Find the area of the other. I'm talking about area now. Area is two-dimensional. I'm not going to use the PR. The PR, not going to be used right here. Instead, I'm going to use the AR, the area ratio. Now, how do I get the area ratio? Well, remember, area is always what? Is always squared. It's always to the second power. So I'm going to go ahead and square. Oops. It's supposed to be 2 right there. All right, I'm going to oh, that's just going to confuse people, including myself. Okay, I'm going to go ahead and square the 1. And I'm going to square the 2. Let's go ahead and just change this color here because the green's getting on my nerves. Okay, I'm going to go ahead and square. Still on erase mode. Let's see. I'm going to square. No, it's not working. Let's see. Okay. Let's see if this works now. There we go. And I square the 1 and square the 2. The new ratio becomes 1 over 4. Because 1 squared is 1, 2 squared is 4. Now, they tell me that the smaller parallelogram, the area of the smaller parallelogram is 6 inches squared. Meaning, if I'm going to put this somewhere, I'm going to set up a proportion. The smaller parallelogram is going to be represented by that 1. So I'm going to put the 6 inches squared here. I'm going to write inches squared just because I want to write it in, make sure I know which unit of measurement I'm dealing with. And I'm going to put an X down here because I'm trying to figure out what is this guy. This one I already know is 6 inches, 6 inches squared. This is going to be X inches squared. I'm not sure what it is yet. Okay. All right, so I'm going to cross multiply. I get 1 times X, which is clearly X. And then 6 times 4, which I know is 24. And then I'm just going to add that inches squared right there because I know it's inches squared. And that's it. So what I had to do here was I first figured out the ratio from 3 to 6. I got 3 over 6. The similarity ratio is 1/2. Now I didn't need the perimeter ratio because we're not talking about perimeter, but we're talking about area. So how do I get the area ratio? I square it. Then I set up a proportion, okay? And I put the 6 inches squared of which was the area of the smaller triangle on top because that matches with the 1. It's the smaller of the two numbers here. And then I put X here to figure out what was the area of the larger. All right, why don't you go ahead and try this one, the 6, before you watch me do it with you. Try this out just because this is something you're going to need to know how to do. Okay, so what's the first thing I need to figure out? I need to figure out that similarity ratio. I'm going to do this in blue. Similarity ratio, what is it going to be? Well, I'm going to reduce the 12 over the 18 because it's 12 to 18. And I know this is really 1 over 6. Now, the thing is, I'm sorry, divided by 6, I get 2 over 3. Because 12 divided by 6 is 2, 18 divided by 6 is 3. The thing is, I need the area ratio because we're talking about area. So I need the area ratio, which remember, to get the area ratio, I always just square the similarity ratio. So I square this guy and I square this guy, and I get 4 over 9. Okay, now I'm going to set up my proportion because I have my area ratio, because I have to have the area ratio in order to do this. Now, they tell me that the area of the larger trapezoid is going to equal 121 meters squared. So since it's larger, I'm going to put it on the bottom of my proportion because 9 is a larger number. It's going to be proportional to that. And then an X up top. I'm going to just extend my page here to give me a little bit more room. This is now going to become 9 times X, which is 9X. 4 times 121, which is equal to 484. And I'm still going to divide by 9 to get what X is by itself. X equals, now they tell me to round to the nearest whole number, so I'm going to use my calculator here. I'm going to do 484 divided by 9. 484 divided by 9. And that gets me somewhere 53.77777. Now, they say to the nearest whole number, but since this 7 is above 5, this X is now going to become, or the measurement, the area of the smaller guy is going to become 54. We're going to write meters squared. So 54. This little guy is the 54 area, while this big guy is going to be the 121 because the area ratios are 4 to 9. So then what we had to do is set it up. Okay. Alrighty. Let's do a couple more. I'll do this one right here. I'll do this one. This is number 8. This is homework for you guys. Okay. So this one, they tell me I need to find the area because it's the same directions from over here. So let me just copy down these directions so that you guys always know what we're doing. So they tell me over here that the figures in each pair are similar. And we need to find the area of one is given, but we need to find the area of the other to the nearest whole number. Let me move this guy down. There we go. Okay. Okay, figures in each pair are similar. The area of one figure is given, find the area of the other to the nearest whole number. So it looks like we have 2 hexagons here. If I have 2 hexagons, then that means I need to find First, the similarity ratio, which is actually going to be pretty simple because it's just going to be 13 over 5. And 13 over 5 can't be reduced anymore, right? So that's the similarity ratio. However, I need to get to the area ratio. And how do I find the area ratio? Think of the little squared. All I have to do is just take this guy and square it. So I'm going to take this one and square it. 13 squared is 169. 5 squared is 25. Okay, and I'm going to set it up. The area of the smaller guy is 65, so I'm going to put him up. Oops, wait. Smaller hexagon. Where should the smaller hexagon go? I almost did that one wrong. Since 25 is my smaller number, I'm going to go down here, and that's where I'm going to write 65. 65 should go down here, where this x for the larger guy is what I need to find out. So I already know that this area here is 65 inches squared. I need to find out what this big guy is, and I'm going to put him as x. X equals, what is he going to be? So it's 5 to 13 squared. So 5 to 13 squared, 169 over 25, is the same as x over 65. So I'm going to cross multiply. This is where I'm going to use my handy dandy calculator. So 25 times x, well, not there, but 25 times x, and then 65 times 169, because it's going to be a big number here. I'm going to take out my calculator. 65 times 169. And what is that going to equal? That's going to equal 10,985. 10,985 divided by 25. Divided by 25. X is going to equal, now they tell me to round to the nearest whole number. So, whoops, I lost the number. X is going to be, since this is a 4, we're just going to go down to 439. Which means that the area of that big one is going to be 439. Okay, and there we go for that one. Pretty simple, straightforward. All right, one last type of problem I'm going to do with you guys is this one here. It now wants us to go backwards. Now, they don't give you here on this number 12, and this you'll see this is 12, 14, and 16. They don't actually give us shapes, but they do say to us, hey, find the similarity ratio and the ratio of the perimeters for each pair of similar figures. They tell us that the two triangles had areas of 75 meters squared and 12 meters squared, and you might say, wait, I don't have any measurements of sides. But you do have the areas, so you can actually compare the areas. Now let's do this. I'm going to set up. Now remember how before we would say similarity ratio and we would say is the same as the perimeter ratio. Those are always the same. That was always nice. And then to get here, we would just have to do what? To the area ratio. We would just have to get the area ratio by squaring these guys. So this would always be squared, right? Well, now we're going from here, 75 to 12, and we're trying to go backwards. Okay, so now what I'm going to first do here is I'm going to take 75 over 12. I'm going to reduce this. This can be reduced. How can this be reduced? Well, I think if I divide it by 3, I would get a good number here. What's 75 divided by 3? Oh, 25. 12 divided by 3 is 4. So really, their ratio for their area is simplified and get to 25 over 4. Now, again, how do I go backwards? Now, think about this. This was squared. What do? If you said square root, then you are correct. I'm going to take 25 and 4. I'm going to square root the number. So what's the square root of 25? Think about it. The square root of 25 is equal to 5. The square root of 4 is equal to 2. So the perimeter ratio is now a 5 to 2 ratio. Because in order for me to go from here to here, I squared it. So to go backwards, I square rooted it. So now what's my similarity ratio? Well, it's always been the same as my perimeter ratio, so it's 5 to 2. And that's how you do that one. Simple. You took the areas, you reduced it, you simplified it as much as you could, you got 25 over 4, and you're like, well, I have to go backwards now. How do I go backwards from the area ratio to perimeter? I square root it, square root, 5 over 2, 5 over 2, and their similarity and perimeter ratio, you know, will always be the same. All right, so that's how you do this guy. And the ones that are there are going to be very similar. Okay, so that's going to be lesson 8.5. If you have any questions, please make sure you ask for help, go to tutoring, all that good stuff. All right, till next class.